Hey everybody on the internet, even you internet trolls, give me your worst, I can take it. How'd you stumble on my site? What were you looking for? Billie Eilish's newest music video and you found an AP Calc review lesson? Well, you're in luck. Let's have some fun. Today we're going to take a look at 2018 number 5. Let's have a look. Okay, so here's part A. They want us to find the average rate of change of the function f on the interval 0 to pi. So average rate of change is the good old-fashioned slope that you know from algebra, m. And slope is change in y over change in x. That's one of the most fundamental concepts in all of mathematics. So I'm going to do f of pi minus f of 0, that's change in y, over pi minus 0, that's change in x. So we're going to plug pi into the function and leave everything in terms of pi, because this is a non-calculator question. Remember, anything to the 0 power is 1, including e to the 0. E is just a number. Cosine of 0, you have to remember what that is, right? So I'm a unit circle person. I'm going to draw a unit circle here. And at 0 radians, oh, let me do pi first, cosine of pi, right? At pi radians, which is 180 degrees, the coordinates are -1, 0. And at 0 degrees, or radians, the coordinates are 1, 0. It's always cosine, sine. So the cosine of pi is -1. So we're going to get e to the pi times -1. I'm going to write that as negative e to the pi. And cosine of 0, you can see, is +1. So 1 times 1 is 1, all over pi. That's your answer. You can leave it like that. That's a good answer. It's a numerical answer. Let's check out part B, shall we? We shall. Here it comes. Part B wants to know what's the slope of the line tangent to the graph of f. Again, that means the derivative. Slope of the tangent line is the instantaneous rate of change. It's the derivative right at 3 pi over 2. So I'm going to take the derivative. Now to do the derivative, this is a product, so we need the product rule. The product rule says the first times the derivative of the second plus the second times the derivative of the first. The derivative of cosine, remember, is negative sine. The derivative of e to the x, it's my favorite derivative. It's its own derivative. The only other function that's its own derivative is 0. So the derivative of e to the x is e to the x. All right, now I'm going to plug in 3 pi over 2. I'm factoring out that negative symbol to the beginning, just out of personal preference. So negative e to the 3 pi over 2 times sine of 3 pi over 2, we'll figure that out in a second, plus cosine of 3 pi over 2 times e to the 3 pi over 2, which is just a number. I'm going to leave it like that. I might even factor it out. Let's see what I do. So I think I'm going to factor out negative e to the 3 pi over 2. Okay, and factoring out that negative will change that middle sign to a negative also. Negative times a negative is a positive, so it's going to be something minus something. Now, sine of 3 pi over 2. Again, I'm a unit circle person. That's my favorite way to determine trig values, so I'm going to draw a circle. It's convenient because it contains every single possible angle of a triangle, so I can figure out any trig value. All right, so here's 3 pi over 2, 270 degrees. 3 pi over 2, down there. So 0, -1. Remember, it's cosine, sine. So the sine of 3 pi over 2 is -1. The cosine is 0. So I'm going to end up with negative e to the 3 pi over 2 times -1, which is positive e to the 3 pi over 2. That's a number, so leave it alone. You don't have to simplify. You don't need a decimal value. That's it. Let's check out part C. We're rolling along. Find the absolute minimum. Now, minima occur at critical values, or they could occur at endpoints. So to find an absolute extremum, like absolute min or absolute max, I have to test the endpoints of the interval, which is 0 and 2 pi, and I have to test the critical values. Critical values are where the derivative equals 0, or undefined, but the original function is defined, right? Those are the only spots you're allowed to change sign. Okay, so let's find out what f of 0 and f of 2 pi turn out to be. And then we're also going to check out the function value at the critical value. So I need to take the derivative and set it equal to 0 or undefined. So the derivative again, I'm going to go back to, I think it was part B where we found the derivative. It's the result of that product rule, right? Here it is. This is the same as we did in part B. And if I set that equal to 0, I'm going to t-bar here because of the zero product property, set negative e to the x equal to 0, and then set the other factor equal to 0. Okay. So I'm going to draw negative e to the x. First, let me draw e to the x. Okay, this is one of the basic shapes that you should know. An exponential curve, e to the x, looks like this. Here is negative e to the x. Hold on, there's an error. This is a typo. Warning, warning. I wrote e to the negative x, but what I meant to write was negative e to the x. Okay, negative e to the x reflects over the x-axis. E to the negative x would reflect over the y-axis. But there's no solution either way. E to the x, negative e to the x, they never equal 0. Just look at the graph. They asymptotically approach it. Now, sine of x minus cosine of x equaling 0 is the same as sine of x equaling cosine x. So where does sine equal cosine, right? And you've studied enough trig that you should know that there's a point in the first quadrant where the coordinates are radical 2 over 2, comma, radical 2 over 2. And that's at pi over 4, 45 degrees, or pi over 4 radians. Now, in quadrant number 3, that's the other spot where they're equal because they're both negative. Negative radical 2 over 2, comma, negative radical 2 over 2. In quadrant 2 and quadrant 4, the signs are opposite, so they wouldn't actually be equal, right? You'd have negative positive up here, and you'd have positive, comma, negative over here in quadrant 4. So these are the only two spots from 0 to 2 pi, once around the circle, where the coordinates of sine and cosine are the same. Pi over 4 and 5 pi over 4. How did I get 5 pi over 4, by the way? 180 degrees, remember, is pi. That's 4 pi over 4. Go one more pi over 4, that's 5 pi over 4. That's how my brain works. So now I just have to plug in all 4 of these values into the original function. And I want the absolute minimum, so I'm going to choose the lowest. So f of 0 is e to the 0 times cosine 0. That's 1 times 1 is 1. Next, f of pi over 4 is going to be e to the pi over 4 times the cosine of pi over 4, which we just found out was radical 2 over 2. All right, so that's a number. I'm going to leave it like that for now. F of 5 pi over 4, let's see, I'm going to have e to the 5 pi over 4. And then the cosine of 5 pi over 4 is negative radical 2 over 2. So far this is the lowest value because it's the only one that's negative. And that may be true at the end. So let's plug in 2 pi. E to the 2 pi times cosine of 2 pi. Cosine of 2 pi is 1. So I get a positive number. The only negative number here is the winner. So the absolute minimum value of f is negative radical 2 over 2 times e to the 5 pi over 4. That's my answer, the absolute minimum. Okay, here's part D. Let g be a differentiable function such that g of pi over 2 is 0. The graph of g prime, the derivative, is shown below. Find the value of the limit as x approaches pi over 2 of f divided by g, or state that it doesn't exist and justify your answer. Okay, so we want to find the limit of f of x over g of x. So the first step for any finite limit is to plug in the value. So let's see if we can find out what f of pi over 2 is. So f of pi over 2, we're also going to find out what g of pi over 2 is from the graph that we were given. So f of pi over 2, we're going to plug into f of x. We're going to get e to the pi over 2 times cosine of pi over 2. And now cosine of pi over 2 is 0. So we're going to get 0 up there. Now g of pi over 2, let's see what's going on there. Oh, they told us it was 0. So we have 0 over 0. This is an indeterminate form. Now there's a theorem called L'Hopital's rule, which says that if you have an indeterminate form such as 0 over 0, and f and g are both continuous, then the limit of f prime over g prime is the same as the limit of f over g. So we're going to now take the derivative of each of these. And if you remember from part B, here's the derivative right here, f prime. So I'm going to plug pi over 2 into that and see what we get. So f prime of pi over 2 is going to be e to the pi over 2 times negative sine of pi over 2. And sine of pi over 2 is 1. So we're going to get negative e to the pi over 2. Also, while I'm calculating this, the beauty of L'Hopital's rule is as long as you get an indeterminate form like 0 over 0, you can repeat the process and you can keep taking derivatives. Okay, so f prime, we get negative e to the pi over 2 power. Now g prime, remember this graph that we were given is g prime, so I just have to find the value of the graph, which is 2. I'm just looking for the y value. Don't take the derivative. It is a derivative. So I get negative e to the pi over 2 over 2. That's our answer. That's the limit of f over g. Even though we used f prime over g prime, we didn't use the quotient rule. We used L'Hopital's rule. So that's my answer for part D. Now, go ahead and check out the scoring guidelines for 2018, number 5, and see how many points you would have gotten. Hope you had a great time reviewing with me. Thanks for watching. Don't forget to hit subscribe to my channel, and I'll see you next time. May the math be with you.